best.
Oh yeah, I accidentally stuffed it up. I took too much out. Sorry about that. I misspelt this here, so I was fixing it up. And then the last one there is the resource group. So yeah, put that resource group in as well. Okay, AI-102. So hopefully. Okay, so the output there has got the app ID, the display name, and the password and tenant. All right, thanks for that, everybody. And we're just going to make a note of that now. I might as well just take that and put that in my notepad. And then we're going to show the ID for the app ID. So let's do that. Paste that one in and just cut and paste it from here. Copy, paste. Okay. Let's have a look at what that's got there. So that's got all the information associated with that app ID now. And we're going to cut and paste that whole thing into, so to copy the ID, copy everything there. That, I'm going to paste that into just into the notepad, and then you can see to assign the permissions, run the following Azure CLI, so that's going to put that in the key vault. So let's have a look at that. Copy and paste that first. So key vault set policy, key vault name. I remember what we called it. There it is. There. That in object ID equals the object ID. So I'm assuming that all of that is now going to be the object ID. I think that's great. And put that in. Oops. All right, let's hope that all works. I'm not sure it's going to work, but give it a go. Paste. That looks like it's working okay. No. Made a bit of a mistake then. What am I missing? Anyone see what I did wrong there? Maybe I don't take those two outer brackets, maybe. Oops, I can't edit that, can I? No. All right, so let's try that again without the main brackets on that. Still not working. Not quite right there. Let's try that again. Still having problems there, so I wonder whether the object ID, I didn't get that right. So I think we're missing a step here, which is to go and grab that object and put that into the keyboard itself. Let's just try that. It's down. Has anyone tried to do this before? It's actually no, it doesn't seem to be working. So, any suggestions? We'll have a look and see if we can troubleshoot this. I'll come back to it. Yeah, Darren.
I thought it said line two or line one. Which one did it say?
As part of this object ID?
No, on the whenever it was showing that you run into an error.
Oh, right.
Yeah, because it says line one or line two, right? So let's see what is missing there. Okay, it says line one. What's the latest error?
It's breaking it up, so it's not, I'm not sure whether the error is as meaningful because it looks like it's got a bit of a break in there. So there's maybe something, and originally what I took out was,
I think at first it was missing the app ID, right? Did you copy paste the app ID in it?
Yeah.
Is it already there?
That was one of the earlier ones, and then, so this was this one here. I'll run that again because I took that down to here. And that was that first one I had, so I'll just do that one again. Paste. And then that one's saying the O data context there isn't right. So I thought maybe this first quote was misplaced, so that's what I was going to remove next. That probably makes sense, and then I might have copied the wrong one when I did that. No, it's causing problems when it doesn't have the bracket around it. So, yeah, the object ID, it's not letting me put that in. Metadata entity. So, let's go and see example of that one maybe. See if we can find an example. So that one is set policy. Let's see if we've got an example of that. So, that's using the GUID, so that's not, must have that wrong. So where do we get the object name from? To get the object of the service principal, run the following. I think that's probably where I went wrong then. Just go and grab that again. I'm looking for the a value in here, not the whole thing, I think.
Can you do a control F for the app ID? Is that what you're looking for?
Not the app ID, but the object ID.
Okay.
Replace the app ID with the current value of the service principal app ID. So that was what I originally did, was the show, and then the next step was this one here. So that's the one that's not working. So let's try this one again, like we did before. Paste, and then we'll put the app ID in at the end, which is basically that. Actually, that's already there. Tab, oh, that's not working. Paste. And then we wanted to get after that, we wanted to be able to get probably the ID value and the JSON. Oh, there it is there. All right. That was me doing the wrong thing there, so that's all on me. Let me just fix this up now. Grab that, and then grab the last bit of that as well. So I was thinking I had to put the whole of the JSON in, but it's just the object ID. That's stupid. Paste, and let's see how we go there. Just thinking. And then once we get that service policy, that's what we're going to use, service principal, we're going to use that inside of, so we didn't have to do anything else in Keybot other than put the secret in, so just waiting for that to come back. All right, I might have to get in there. So the MSI is configured correctly. Just go back to the previous commands. So that was the create, that was the SP name there. Right, so that was created. That was created, yeah. It looked like everything was okay, but we're still having problems with just got that error there. Oops. I'll just run it again and see if we can find that error message. So we might have to continue this one a little bit later because we're having issues with it. Just record the error and we'll see if we can do that part 2 this afternoon. Work out what's going wrong with that. And we'll grab that. Alright, so we'll look at that this afternoon and see if we can work out what's going on with that and debug that a little bit further. So it could be that the instructions are a bit out of date as well, so I'll double check that, see if there's anything we missed. Other than that, it was then going back to the code and using the key vault, so we'll see if we can get that working this afternoon. All right, let's head off to our next hack, and that's going to be our vision. So we'll be able to see some really cool APIs with this one. Just setting that up. Okay, so with our vision, what we're going to have a look at is we'll have a look at that fruit bowl example. So we'll do bananas, oranges, and apples. And we'll also then do another so we can classify each particular one, and it'll give you a confidence score of what, how sure it is an apple, orange, or a banana. And then it will, in a fruit bowl, it will show you then how to put those bounding boxes on each of the fruits as well. So I think you needed from memory, about 15 images for that last training effort. But I can show you how to do that. You'll be doing in the labs in your in the AI vision, but I'll show you how to do it in the custom vision. I can show you how to do it in the, you'll be doing it in the custom vision. I'll show you how to do it in the AI vision as well. So for that one, you just need an Azure Machine Learning workspace. That's not too expensive. You just need a bit of GPU. And when you create the GPU, it'll ask you to create a new GPU, but it will have to be a non-dedicated GPU in order to use that. So I don't know whether they've lifted that policy on the subscriptions that we've got at the moment, but that's one of the restrictions we've got, and that's the concern around the spending on GPUs, for example, and doesn't get out of control. So we'll also learn, how to detect faces, and we'll also use the video indexer, which allows you to look at videos, pull out pertinent information, any images, and also can be used to identify known people in there as well. So we've got a few famous people in there. Not that famous, they just say they work at Microsoft, but yes, you'll be able to find them in the image as well. So let's have a look at analysing and manipulating images, so that you can go and manipulate them later. So you can pull out different sections of the image. And of course, if you want to do further image analysis after you've looked at these custom vision, then one of the things that you might want to look at is computer vision down the track, where you can actually go and start to manipulate through things like convolutional neural networks or other techniques as well. So you don't have to just stick with the AI that you've got. You can then use open source to do other things with it as well. So we'll look at the features associated with the image. We'll have a look at optical character recognition. So a lot of that is used in documents as well. And that technology has been around forever. I think since I've been in IT, maybe not quite that long, but and also look at image analysis APIs as well. So that's the first one there. There's a few different options you can return. So when you're going to call the API, for example, you can bring back various things. So in the case here, we've got an image. It's kind of a caricaturist type image, but it's got a mountain in there, it's got the sun, and it's got a couple of mountain peaks there, and I wish you were here is the text on there. So if we take that as input into the services, then we can basically use caption to actually caption that. So a mountain with snow as the caption. And then you can bring back these tags as well, which is things like outdoor mountain snow. Just depends how many it's picked up there. And with that, you can also pick up where the mountain is in the image as well. So when you're doing something like a thumbnail, it will keep whatever the focal point is of the image, it will keep that front and center so it doesn't get cropped off. And then the other thing is using OCR to actually pick up, wish you were here there. So it's picked that up. The smart crop, like I said, keeps whatever's in focus there in the middle so that it doesn't do a bad job of cropping it to make it smaller for your other needs. You can also have multimodal embeddings. So with multimodal embeddings, quite often in 3D space, you might want to refer to something as possibly an ID. So normally in the large language models, you would use an ID there as embeddings to show where it is in 3D space, but you can also use other things in some of the other services as well, like these embeddings. So I'll just see if I had that there. I might go and grab some more content on that later, just so we can see where's a really useful way to use embeddings there. So usually in 3D space, you might have cat and dog located fairly close together, so the way the language model is predicting that next word, it tends to look in that 3D space to work out how far concepts are away from one another, like dog and cat. And again, you can use this as the AI Vision specific service, which might be free there. We might have a little bit of background noise, so I'll just put everyone on mute. And but come off if you've got a question. Don't worry about that. Or you can use the multi-service there. So again, you get some free versions if you go into the specific standalone service there. So let's have a little bit of a look and see. Let's get Copilot to help us out with this. I always like to get Copilot to basically help us a little bit with when we're not quite sure about something like that embeddings, how we're going to use it. So let's go Copilot. I have, I want to say hi first. I have the Azure AI Vision service. What does multimodal embeddings option do? And let me know a good use case to use that at work. At a tech company. So let's see if we can, so give it a little bit more information. So what is it using there? Vectorization. So again, that's where it is in space. Usually when you're taking something like an image, you would embed that, and then you could use that in any of the services as well. So that's that input that the convolutional neural network would take. So you can actually make that smaller by summarizing the pixels so that you can actually get a much smaller vector or matrix to feed into that. So they're talking about vector representation, so they're usually numerical. You can do it with images and text, so that's interesting. These embeddings capture the content of the context of the data, enabling you to perform those searches. So again, the semantic search would be so that it was, I suppose, syntactically correct, like it wouldn't break off on a particular, if you were searching that way for the next word and you were using input, it would, when it's doing a search, it would make sure it goes to the completion of whatever that is, a sentence or a paragraph, and then it would actually work out based on the semantic meaning in the sentence rather than just the keywords there. So vectorization, high dimension vectors, and then they're converted, the text and the image there, for example. And then these vectors are compared using distant metrics. So again, like I said, if you think about the 3D, if you think about the 3D sort of, it's a pretty poor one there, 3D space, and then you basically got various values here. For example, cat might be here in 3D space and dog might be over here. Then you can sort of see how close they are together, and then you might have fish here as well. So, and then over here you might have car and driver just here as well. So just seeing how close they are in space as associated with all of the sort of sentences that are used out there, to see how close they are related syntactically in your sentences there, semantically. So that gives you that idea of some vectors that are then sent to these. And of course, large language models is a good example of how they use that. So just see if there are any other information here. Customer stock, retrieve relevant documents. All right, so let's have a look and see whether we can find this anywhere and learn. Get rid of my silly back to the thing. Multimodal embeddings there. So they're talking about, in particular, image tagging. So it is part of the image service. It's not part of the large language models. So let's have a look. Difference between a vector search and a keyword search. A bit on that. And there you go. Probably the use cases are going to be more surveillance oriented, like you can see there, but also you may want to drill into very specific information around fashion and design, e-commerce, there you go, forensic and surveillance. So these could be some of the use cases you want to use that for. And there's a good example there where you've got photo library and you've got it vectorized, and then you've got the values there. So that one looks interesting as well. And then between a query, just seeing what it returns. The input, there might be some restrictions on the size. So you can see there 20 megabytes, 10 by 10 pixels, 1600 by 1600 pixels. So that's quite a large space that we're looking at there, or size of the images. And there you go, you've also got some limits around the words if you're using that. So that's why it's multimodal, because it's looking at both text and images there. So that's usually where that term comes from. Okay, some of the other things that you might want to use if you're calling the API is a good example of using REST and then the SDKs there in C# and Python. So in this case, you can see captions. That makes sense, right? We need to see captions. The other one is dense captions. So just double check that one this morning as well. That's an interesting one because it actually allows you, it returns a lot more when it returns the information. And what you can do is see what's in different sections of the image. So if you were to put a bounding box around there, you could just have a look at one particular section. Especially if there's a lot going on in the image, you may prefer to have captions instead, because you might have different things going on in the one image. Tags there make sense. Objects, so the objects associated. Also smart crops, like we said before. So also people and read are some of the options there. And the analyze, that will actually call, using the image, you'll need a file or a URL. And that's what's going to return all these information, depending on what you're grabbing. And so it's all about which ones you choose here. You don't have to choose all of them. And then you'll see which features, language, and other options. So you've got an ID returned in there as well. And here's the two examples here with C# and Python, and there's that REST example before. So again, it is important to see what versions you use, and I've still got that question outstanding there from before as well. So here's the analysis options, cropping ratio. So you can get a little bit more detailed with these sorts of things. Any of the features you want to pull out, maybe in the features. Gender neutral captions, so not having, that's all around accessibility and, and I don't know what else to say about that one, sorry. Language, but also the model name, the version, and the segmentation mode there. So I think I actually had some notes on that one. Some of these are just what you are telling it to use, and if it has the word return on it, then that's the one that was used. So for example, you could say to use this model name and version, and this type of segmentation mode there as well. So here's a few examples with C and Python. But if you were to say return before that, it would actually return those values, not just use them. So here's the JSON response. You can see the caption at the top, but also a confidence score. So it's pretty low, a man pointing at a screen. This one was actually, because I've seen this example on Learn, that one is actually using that dense captioning there. because it's looking at a particular point in the screen. But it's only returning that first caption there, which is interesting. The objects result, so it's a string, and this is the confidence score for that. And then the smart crop, so where that the aspect ratio and the bounding box there as well. So this is basically everything that gets returned from this particular example. We still, actually, we can't really see the example that produced it. They might have several layers there. So again, there might be a very complex structure of JSON in there. All right, let's continue on before we do the lab, and we'll just have a look at OCR next, just because I want to make sure that we get through the content and you get to do labs together, because that might be more beneficial. So let's keep going, and then we'll have that break for the afternoon tea. Okay, so OCR, again with OCR, you can actually see, you could use OCR or document intelligence. I mean, OCR is in document intelligence already anyway, but you can use a document intelligence if you've got a really big document and you've got similar things coming in over and over again, then maybe document intelligence might be the way to go, but you could also use OCR as well. So you can return it as a JSON request result, or you can look at returning an object in the SDK, and then you can use that further in your code. So here's an example where you must be the change you see in the world. I think this particular one was. And you can see the bounding box around the words, and then it's broken it down into individual words itself. So there's the line and there's the word. So you can actually break that down into very specific information. And when we go into Document Intelligence Studio, you'll actually see it a lot more clear in the JSON output as well. So we'll have a look at that. So there you go, OCR general documents, smaller amounts of text, and you can have synchronous API. So that means it's quick enough that you can wait for it to return before continuing on. And then the document intelligence, that one's going to be asynchronous. So it might be in a batch type situation where you load in a whole lot of documents and then return all that information. So for larger, heavier documents there, that's the main difference why you use them, the different ones. Right, let's have a look at detecting faces. So we're going to use the face API, but of course with this comes a little bit of warning, because usually you have to apply to use the face API. So historically speaking, that's a bit of a minefield when it comes to personally identifying information. So that's where when there was a while back, there was a bit of a discussion about police using it and things like that. So since then, a lot of the tech companies got together and they make sure that people do get approval before they can start using it. So they apply in writing to get this. So you can see it says it's limited access there for the face. The image analysis, not as much. You don't have to worry so much about that one, but it's when you've got the comparison, the recognition, the identification, that's the bit that needs we need to be very, very careful about. So first one there is image analysis, so people detection. Is there a person there or is it something else? And then only the location is provided for the image analysis. So you can see an image like this coming in, and in image analysis just saying this person's location on that file, on that image, pardon me. But when you have a look at the face API, you can actually see that there's a lot more options. So even the way the head is posed, whether it's to left, right, or, tilted, anything like that, and, facing a different way. The location, of course, in the image, any of the attributes, so whether they're smiling, whether they've got things like glasses on, I don't know whether it can detect contact lenses, maybe it can. If you had something to compare, landmarks on the face, so where the nose, cheeks, all the different identification points are. And it can also be used to compare to other images. So you can see in this one, you can do comprehensive facial features, but also face comparison identification, which is a little bit scary. So that's what Windows Hello is doing. It's probably using not exactly the same thing, maybe customized specifically for Windows, but that's one of the better security recognitions that you can have. Often we're using that now as a mandate at work, that you prefer to have that with your laptop. And then the secondary one is a passkey, is the next best thing to use with that. So that's sort of how our security works for us. And then, of course, being very mindful of some of the elements of responsible AI, so especially around data privacy and security, and what is stored behind the scenes, how long you keep it for, whether it's persistent, so if it's part of your security systems at work, perhaps that's going to be persistent, but if it doesn't need to be that way, if you're just doing a quick comparison, then that could be destroyed within 1 day, so 24 hours we might keep that for. Just depends what sort of use case you're looking at. People are told when they're going to have their image stored, so if you're thinking about using that, just make sure it's quite clear that people are being told about that, so be transparent. And fairness and inclusion, so we don't want to have prejudicial to individuals based on their appearance or unfairly targeting individuals. So I think if we've seen some of the stats from America based on your facial recognition, they've got, like, I was watching something that had stats on it the other day about how many people were getting pulled over by police, and there were three particular ethnic groups, and how often they were pulled over, and saying, oh, it's okay because it's a third of the population. But in fact, when you had a look at how many people were being pulled over versus how much that was representative of the actual population, they found that it was heavily skewed. So little things like that, you have to take the statistics with a bit of a grain of salt and do a little bit further digging. So fairness and inclusion in there as well. All right, so some of the facial detection is head pose, like I said, glasses, whether it's overexposed, it's got blur, whether it's got any occlusion so you can't see the whole face, any noise, any bounding boxes. So these are all the things you can pull up. And of course the facial landmarks, the things like nose, eyes, mouth, that sort of thing. You can do facial comparisons between two. So if you've got a whole lot of images, there's the landmarks there, so it's telling you actually where is the main part of the face bounding that box. And facial comparisons with other images. So for less serious things like taking pictures and then grouping all your pictures together, that's quite a nice way, just for some sort of hobby. And facial recognition, of course, we can tell that's Joe. And liveliness, so facial liveliness, I meant to go and have a look at that one. Let's go and have a look at that now. Oh, there it is there. I did go and grab that earlier. Let me just go and find that. I don't remember what you've done so far, sometimes. Okay, so abuse monitoring in face liveliness detection. So detects and mitigate instances of recurring content and all behaviours that violate a code of conduct. So this one's a pretty serious one. How to work with these features to ensure your application is compliant with Azure policy. So session management, your back-end application system creates liveness detection sessions on behalf of your end users. And the face service issues authorization tokens for a particular session. So then if you don't try to present that face again later, it's not going to work for another session, for example. So when the end user encounters a failure during liveliness detection, a new token is requested. So that's not so much about whether they did it right. That's all about making sure that it's the right one used for that particular session. Sounds dire, doesn't it? Temporary correlation identifier, so there's a GUID assigned, and is also looking for patterns of abuse as well, and various other things. So have a look at that one as part of that. And it can be used as a standalone or again as one of these overarching or services that does multiple things. So you can do, or if you want a standalone one, there you go, you might get a free version of that. So that could be good. And then I'll just double check these two. The identification, so when you've got just the identification, it only is identified for 24 hours. So this is one type of service you can use. So then it's gone after 24 hours, and it can be used to verify the faces, you know, and compare the faces there, like similar faces. But if you're going for the persistent face recognition, then you might have a group of authorised users that you've created. So you create a person group, and then you add each person as individuals, and then you add multiple detector faces for each person, and these can become persistent faces, and then you train the model there, and then you can identify, verify, and find similar faces for that person. So this is the one that's actually persisted and stored. So this is the more serious option there. Mohammed, what were you going to say?
Yes, Jane. So this is something interesting, Sometimes we don't even recognize our own picture because when we take pictures at times it comes totally different.
Yeah.
How come the technology recognizes these things? I'm trying to understand. Do you have some idea? Just explain if you can, please.
Yeah, I don't really understand how it can do it, other than the pixels are slightly different. But it's the same with the X-rays, right?
Right.
Doctors are baffled as to how it can detect things it does, and do so much a better job than a human can. And even with things like, it's interesting because we all just got together for an offsite, and I hadn't seen people like ever since I worked at Microsoft. And of course, what's interesting is people never look like their pictures on LinkedIn or their Microsoft pictures.
Yeah.
I think so much to do with lighting has an impact, whether you've
Right.
got a long exposure, short exposure. There's so much to do with images, isn't there?
Yeah.
So,
I understand the attributes, like, okay, it's tilted, you're wearing glasses, or maybe something else. Yes, that's easily recognizable. But how do you really compare two images? But anyway, we'll see how it comes or how it unfolds. Thank you very much.
no, that's good. Did anyone else have anything they wanted to add to that? That was a really good question Mohammed mentioned. So, Daryl, it looked like you were going to say something.
Oh, I was going to say the differences sometimes in the quality of picture or in the picture versus the actual person is also dictated by the type of phone camera that they have.
Yeah.
For example, a lot of Asian phones, they make people light skinned because that's what users want. There are those, yeah, because you have the ability to automatically correct or enhance the picture. So there's those. So anyways, I just wanted to put that in there. And then, in the deciphering who is who, or the delta between the real picture, the real person, and the picture on the profile.
Yeah. So I think
you made a good point. I'm very sorry, Jen. Just trying to make another point here. See, sometimes when we look at some specific, you can say, I mean, for myself, I'm telling, and this is not kind of racist thing, but sometimes I cannot recognize Chinese. I mean, they all Chinese look same actually. So this is something unbelievable. I mean, I trust it that the way how it's doing, there must be some guidelines how it compares. If it makes some kind of like graph on top of the face, so it matches some coordinates, and then it understands that okay, the eye size is in this length, this uh, direction, or width or height. I mean, there must be something.
Yeah, because people change as well over years, and perhaps it will fail if someone's put on weight, or I've noticed even with the latest version of Windows that if I really wanted to go in depth, I have to take the second picture with the glasses off, used to just try and work that out and take a lot of different pictures. But I've noticed the new version is snap like that. It's so quick compared to in the old days where you used to have to stand still and it had to find all the features. Turindeep also says, can it identify faces generated by AI? So it's generated by DALL-E. I don't know whether it can do that, but then again, that's the slippery slope. We talked about this in other courses with AI, generating the data and then AI actually looking at the data to try and label it. It's like, yeah, that's a bit of a slippery slope. They're just going to have AI talking to each other about its images. But I'm not sure whether it can. Let's see if I can find a little bit more about that, because there is a whole lot of science behind this. And I think one of the things it does is, I think it can also do that wireframe sort of the person's outline, just the outline can help as well with the detection. So let's ask Copilot, can you show me the mechanics of facial recognition? Because I suppose one of the best things is it's not only can it see better, I suppose it can also hear better as well. So the audio is getting better as well. So yeah, behind the scenes it is using convolutional neural networks. The bigger it is, the more precise it's going to be. But typically with a convolutional neural network, you're trying to cram everything in and make it smaller. So the images usually lose some detail. But with facial recognition, I wouldn't have thought you'd need to. There you go, 80 nodal points there. So I've just typed on something quite random. I probably shouldn't have done that. But 80 particular points. So that's all those landmarks that we talked about on the face before. Skin texture as well. So they're using convolutional neural networks there. Kernel methods, PCA and SVM, support vector machines and principal components. So supports not faces in a two-group classification approach. Thermal cameras, although that's not used in every case, of course. And there's also that FaceNet developed by Google. So yeah, it's interesting, isn't it? So here's some information from Elago. AI facial recognition involves three main steps: detection, analysis, and recognition. Detection, and it is a face analysis. That's all the distance between the nose and the eyes and that triangle there. Recognition, pretty cool. And then used to unlock things, so I like that one. Thanks for that. Good discussion. It is an interesting area to get into. I was trying to find in Microsoft Learn, they actually have a page where they have all of the measurements between the particular the landscape, you know, the different parts of the face, but I can't think of where that was. I do remember it, so if anyone finds that one, facial features landmarks for Azure Face API. Maybe we'll find it, maybe we'll get lucky if we just do that. There you go, it's got all the, oh look, there you go, the tip of the nose, pupil left, pupil right.
So it's a very scientific way of covering.
Yeah, I don't think it's necessarily, there you go, that's what I was thinking up there. So
can we get the link to this, Jen?
Yeah,
thank you.
That was the one I was thinking of when Mohammed was asking about it. There's a lot involved, and as you can see, it's not necessarily a lot of AI, it's just storage of the different points. So I suppose it's using recognition, which is AI, and it is using a neural network. But apart from that, there's more maths in it than there is, training images. I suppose that's the main difference. The same image over and over again, or the same person over and over again. That's pretty cool. All right, good one. Good discussion. Here's a good example here of face detection with the AI vision, and even with this particular one, they have a go at working out the age of these two girls, and I'd actually say I could tell this girl was slightly older than this girl. I think this girl's must look completely different by now because this is getting a bit old. But there you can see the people left, people right, like we just saw the face rectangle. And so be on the lookout for things where it says return versus detect. So this is which model it's going to be using, the recognition model, the detection model, and this one will actually return what that is. So it will let you know the version and things like that that's being used. So that's important too. Yeah, with that, those two pictures of those girls, they actually said one was 36 and one was 34. And I could believe that. All right, let's have a look at custom vision. And this is where we might not have as much time to do a demo today. We'll see how we're going. It's pretty much just going to be what you've got in your lab. But what I might show you instead is using Azure Machine Learning instead so that you can see a comparison. So looking at the custom vision model, we're going to send, that's the old style model. So that's going to be the hummingbird on the front. Remember I told you that was the older one. You can try and use the newer one later. So I would use Azure Machine Learning and I would then use image classification or object detection with that. So that's all about labeling the data and then using custom vision model in an application. So how you would then call it. So there's the older one, Custom Vision AI, Vision Studio. So remember I said there was an old one and a new one. This one's still relevant. This one uses convolutional neural networks. This one uses transformers. So the later one is a little bit more modern technology, so it doesn't need as many images. This one needs a few more images. And you can do also, now you can do product recognition as well. I don't know why that's just on that side, but you can do it for both. So image classification, object detection, and product recognition. And then with the labeling, you would use custom vision.ai. So you'd stay in that same area when you go to label. You'll be doing that in the lab, so you see that firsthand. But when you're doing the labeling for Vision Studio, for AI Vision, that one is actually going to be for using COCO files. So we're going to generate a COCO file based on the AML and setting that up and using the labeling of a project. There you go, there's 15 images versus 2 to 5. So a big leap between convolutional neural network and transformer. And I think that large language models like GPT Omni, for Omni, probably use transformer instead of convolutional neural network. I have to guess. Does anyone know that, by the way? We can double check that. But if anyone knows for sure, GPT Omni, what it uses, that might be helpful. And there you go, training data uploaded to Custom Vision, used in storage account, or you can upload it on the go as well, so you don't necessarily have to use that. So that's what you normally do, upload your images, label, train, query. And then you can use that, and once you do the training, it will let you know the percentages. And there's usually, with the custom vision, there's 2 modes of training. One is a few minutes, or even a minute or so. It's not going to take very long. That's the training you're going to do. When you do the training for, there's a second type you can choose, which is a lot longer training. So that's for like 2 hours. And that produces better results. It does a lot more, it probably doesn't summarize the images as much, and therefore it takes a lot longer in the convolutional neural network. So that one is a lot more accurate, training it longer. So I did see that I was getting like 60%, 50%, 60% with the few minute training, and that was on those x-rays I was talking about before. And then when I went to the 2-hour training, I was getting 80 and 90% accuracy. So it was doing a lot better job if you train it for longer. And the same is to be said for the new custom AI vision as well. So both old and new have those 2 options. Mohammed, what were you going to say?
Yes, so Jane, trying to understand, when you say train your model, what does it mean actually?
Yeah, so you bring the examples, and the examples are already labeled. So if you've got an orange, you'll bring in an orange and it's labeled orange. If you bring in an apple, it's labeled apple. so that when you go to train it and you show it a new image, which is the inferencing, the production part, where you actually send something for real in production, it doesn't have the label, so it's able to then label that. So the training is teaching the model how to recognise it's an orange, an apple, or a banana, based on the images you have, yeah.
Okay, and in the previous slide, you were showing two different subscription model, right? Like Visual Studio and Custom Vision. So these are two different portals.
Yeah,
so
yeah.
Which one we are entitled or will be using here?
You will use in your labs, you'll be using this one. So that's the older one. You'll be able to tell that because it's got a hummingbird on the front of that one. That's how I always recognise that one. I don't know why they've got the word custom there, only just tell you that you can do the training, basically. This whole idea of using the word custom in our AI models, in our cognitive models, is all about you can train it if it's custom. You don't have to take an out-of-the-box option. So I'll just remove this for a minute, only because it confuses what the difference is between this one and this one. Okay. So call the old one custom vision, call the new one AI vision. That'll make more sense.
And being enterprise customer, do you think that we are subscribed to it, or is it something very special and we have to do some licensing for this?
No, that's okay. As long as you've got Azure subscription, you can actually use either of those, whichever one you prefer.
Oh.
Okay. Yeah. This one's more, I'd say, like, I'm probably wrong, but I feel this one's more, it's been around for a lot longer, and convolutional neural networks was very much the cornerstone of identifying images. Transformer is a newer technology, and I suppose in this case, it's a lot more transportable the way you use it, because you generate a file that actually is a JSON file of all the labels. So, for example, it'll say, here's an image here, this is where it is, this is its ID, and it's saying that it's an orange. So that label will be attached to that image in JSON format. So that's basically what the output looks like. Whereas this is all stored within the Vision Studio, and it just works out all that behind the scenes. This is a lot more transparent because it generates this Cocoa file for you as well. So it makes more sense, yeah. Okay, so, and then of course there is a big deal with the difference of the numbers. So again, in the old days, 15 images, now 2 to 5. And you know, that's the same for, that's why I said I think Omni is using the same thing, because you only really need to send it 2 to 5 and it works it out. So that's why I think GPT, large language model Omni, version 4 Omni, is actually using that one, that sort of technology there. But if anyone else has any other ideas, because I don't know what's at the back of them, so let's have a look. So I think that was the output there, the Cocoa files is what they look like. So you've got a bounding box around where the orange is in the image, or where the banana is in the image. You've also got some metadata associated with the image, and also its label. So there's a label down the bottom. For this ID, for this image, it's named Apple there. So that's why it's important. Actually, we'll look at the sides a little bit further. So this is the apple, banana, orange option. This is in a fruit bowl. So that's what I was saying, just a collection of fruit. It can actually work it out where it is in the image itself. Now you put those bounding boxes around there to tell it what to do. So you get an image that doesn't have any labels on it, then you put a square box around it. The labeling software allows you to do that. You identify where it is in the image, and then you label it as apple, orange, or banana. So that's actually what you would do with object detection to try and work out where that is. And this is basically all these little boxes are pretty much the ones you do. You come over here, you label it, and then you choose whether it's apple, banana, or orange. So that's how you set this up. So in this particular case, create project, select the resource, add your data set, whether you want to go image detection and classification, set in your Cocoa file, and then you say you're going to bring up the Cocoa file, and then you train a new model. So, Turinder, what were you going to say?
Okay, so my question is more towards the real life experience. So if you go to the shop and buy an apple, no one of the apple is of the same color and size, right? They got different variety, different color, different texture. How that will be feasible in the real-time project? The different shapes and colors of oranges as well.
Yeah.
How that will work in a real life practical?
Yeah, in the real life practical, you wouldn't just rely on the 15 apples. You would take a few different apples. So you take a green apple. The red apples are probably going to do pretty good. So if you're trying to determine the difference between a Fuji and a Red Delicious, maybe apart from the shape, there's not going to be a huge amount. So if you wanted to go to that next level and say what type of apple it is and what sort of variety it is, then you would need a little bit more data. But the more data you can provide it in your data set, you'll notice there's a mixture of green apples, there's a mixture of ripe bananas and unripe bananas. So I did that experiment. I went and picked an orange off the tree when I actually used to teach this, and I had an orange tree. We had to take out the orange tree, but I went and picked an orange off the tree. So the oranges off the tree that you get in your backyard are obviously going to be organic. You're probably not going to spray them, and of course they have a whole lot more dots in them and bugs and marks on the skin and all that sort of thing. So when I get one of those, it was actually able to pretty much predict oranges. Even with the 10 images of oranges, it was still able to work out it was an orange. And then if you go the other extreme, I had a very ripe banana. It was able to work that out as well. And a strawberry, it knew it was the odd one out. But then again, I put my face in there to compare with my face, and I ended up being a banana.
So I think in the real life implementation, what will be the implementation of these images like for the agriculture, for the farmers? They can scan the trees and find out how many fruits are rot, how many fruits are needing like a treatment. What is the practical implementation?
It could be that. I think that's a good example there. I think Daryl was going to say something. What were you going to say, Daryl? And then I'll go and check on.
I have a contact on LinkedIn where he made an app for different skin shades. You know how women wears different foundation colors depending on the hue of their skin. That's what his startup is about. So you can imagine the amount of data he needs to put in there for the different human shades. Because I'm brown, but I'm a different shade of brown compared to somebody who is from who works more in the sun. That's just an example I'm saying. So those are some of the use cases. And then the other thing that I wanted to say, I was asking Llama 3, which is Meta AI. It said that if a simple classification is 100 to 500 images, and then a real world example is the COCO dataset, 120,000 images for object detection, including Apple. And then Stanford has 100 to 500 images for simple object recognition, including Apple. And then ImageNet has 1.2 million images for 1,000 classes, including Apple. So that's what I got.
Good work. I love the stats.
So that's already available, is that what you're saying? Those things are already available and accessible?
Yeah, there are some open data sets that you can look up online. If you want to find out, there are publicly available data sets that can be utilized as well. And some of them are labeled as well. So you can look that up.
Yeah, I think we should be doing work on this data rather than taking more our own photos. Much easier.
Well, then there's going to be some examples where you definitely want to bring in new data sets. So, for example, the new one that I was thinking of was something we did as a hackathon the year before last, which was silicosis in x-rays. So trying to work out whether people had that lung disease from cutting the artificial stone, because the silica gets into there and rips apart their lungs. So that was a relatively new use case because doctors hadn't seen that for many years. And of course that turns up very different from pneumonia. There's an example there with pneumonia from lung cancer, all those sorts of things look slightly different on X-ray. So that's where you're going to want your own use case. It might be for a startup, like Darryl was saying, or you might be able to, if you've got a regular sort of use case, then you might be getting one of those open data sets. So there's the one for government, for Australian government. So they've got a whole lot of data there as well. I was trying to find the particular ones that Darryl's talking about. Maybe we can find those a little bit later, but there is an open AI. Is that it there? The World Bank of Data? That one there? Oh, that's the food bank, is it? The seeds and all that sort of thing. To have a look at that one. So that's World Bank of Data. Now, Mohammed's been waiting patiently for us to answer his question. What's up, Mohammed?
My question is related to this training the model, like custom model. Like in some cases, if we don't have the sample data or sample picture, how do we train it? Is it something using some text, giving some attributes, or what are the possibilities?
Well, you can generate data, but I wouldn't recommend it. Darryl was going to say something. Go for it, Darryl. Go for it.
So AI is very data intensive, right? So that's one of the painful things. That's one of the harsh realities about AI, is that you have human labelers that they have to then label the data and then feed it to the model. That's how it is done. So that's why if you want to have quality data, you have to label them. The other thing that companies do is, of course, web scraping, correct? So they do web scraping, which is legal, because having those images that are publicly available, they get those, and then they label them, and then they feed them to the model. But the labeling of the data is a very human intensive form. Now, if there are models that already have pre-trained data, for example, you are a hospital and you are just interested in images for your X-ray department, there are models that are available already that you can buy. Then if you just want to specialize in this very small field, for example, for young children, then you will just you will just train it additionally for those special images that you already have with your company. So that's how I understand it is being done.
Great explanation. Thank you very much.
So let's have a look at it now in action. So thank you for that. That was good answers there and questions. I suppose when it comes to that hackathon we talked about, I went and got a whole lot of things off the internet which were labelled silicosis, either CT scans or X-rays. And I suppose with this one we're going to be sticking to things like images of fruit and things like that. So let's just see how we would go and create that. Now you're going to be doing this in your lab itself. So I'll show you a different example instead, which is to go into Azure Machine Learning, which is the more modern way to do it now. If we go into Azure Machine Learning, to go and create that, I'll just show you, just because you might not have seen it before. I just search Azure Machine Learning, and it will go and,
sorry for interrupting you.
Yeah. No, it's good.
Yeah, so first Darren, so I was just curious to how to crawl through the web to find out relative images. So for instance, if I put picture of Apple in Google, it gives me too many images of Apple. It also gives me image of Apple iPhone, right? So that's again you need to do more work to understand the scraping of the web, to understand that the image has alt text, to ignore them, because it's iPhone, it's Apple Watch, it's not Apple. Something like that, because something are relatively similar, and then it will confuse the data. So there's more engineering required, not only manually, highly intensive data-oriented tasks to make sure you have the right data, going through the world, going through all the websites and finding the relative images. Because a lot of brand names using those fruit names or stuff.
Yeah. So I suppose you can use groups that will actually label them for you as well, so you can do crowdsourcing for that. But Yeah, I think Daryl's going to suggest something as well. Did you want to suggest something, Daryl?
No, so I wanted to say that there are some worthwhile costs for example, there are some like nonprofits and they need help, and that's what they do. They do crowdsourcing, right? And then what other companies do is, for example, this is a pet project for you. You can just um, go to Upwork or places where people do contract jobs and say, hey, these are all the pictures that I have, label each and every one of them. So that's what you do. Now, you were asking about scripts. There are a lot of Python scripts. That's a very well-known thing that can just crawl the whole www. And then, but the labeling part, like I said, the prep work is the most time-consuming, resource-intensive piece because garbage in is garbage out.
So well done. Good on you. So good.
Yeah, I think that's true. Yeah, I agree with you. I think it is drawing a rectangular where it's hard. How can you do it with program? Right? It's a labor-intensive job. To make AI alive, you need a lot of hard labor for even a small POC.
So I think what you're seeing more and more coming to this is large language models to the rescue now. So what's happening is in a lot of our Azure products, you're starting to see creep in automatic labeling. So I think that's only in its infancy at the moment. So it can recognize images and have a go at labeling those. Now, I would say when I used OpenAI back when it was released as 3.5, I had a few different examples where I sent in an image to see whether it could predict. It said it was going to need thousands of images, so instead I used a custom vision and just called it through OpenAI. But now that we have Omni available with the GPT-4 Omni version, it's getting better and better at images. And when I actually sent it images of the silicosis, for example, it did a pretty good job at working out the difference between silicosis and non-silicosis. Now, I don't know how it was able to do that, but it was pretty good at doing that, even better than the custom vision. So it's something that we're looking forward to for the future, plus the automatic labeling, I think. So I'll give you a little bit of a taste of it, which is the data labeling. I'm in Azure Machine Learning Workspace, and you can say that fantastic questions and answers, everyone. We've got this data labeling tool. We go and create a new project, and then you have these options now to choose. So it's a lot more in depth than the previous labeling in the custom vision that we had before, because it will not only do image, it will also do text and audio. So as part of that project that I was talking about, the silicosis project, they were planning out to go into mine sites and places where they're doing a lot of manufacturing as well, and getting a whole lot of people and screening them all at once. So there's your data set getting created. And that one is also would have taken audio as well as stethoscope recordings as well. So, and also text in the form of doctors' notes and things like that as they saw each person. And that's what they were going to do. They were going to do screening for silicosis. I don't know if that's off the ground. It was as part of St Vincent's Hospital in Sydney. I don't know whether they got it off the ground yet, but that was where they would create a whole lot of data sets there that'd be useful for the future as well. So if we just have a look at these cat and dog ones as orange and apples, for example, we just take the image. So we want to say whether it's an image classification multi-class. Is it an image classification? Let's see. What did I say? Oh, multi-label, pardon me, multi-class, multi-label. So in this one, you would have bounding boxes, polygons if it's a little bit unusual there. So you've got some segmentation differences there. And then this one I haven't really used, so I don't know too much, semantic segmentation. So it's taking the meaning of something there and using it, but don't ask me too much about that. We're not really teaching you about this, but just a way to be able to do this. Then, of course, you can use text and you can use audio there as well. There's only one audio. If you go and use multi-class, I'm going to say, let's call this fruit, and we say next. So we just have to give the project a name. Now, it's going to use, sorry about that, there you go. There's the first step where you can go and get a labelling company in your Azure Marketplace to do that. So you might want to use a workforce there to do that. So it's part of your process. And then you go and create your data. So in particular, I'm going to get the data set for fruit. And it's going to come from a set of files. Now, interestingly enough, because I'm in Azure Machine Learning, I can load that into an ML table, and I could then label it this way, or I could actually go over to automated ML and use the data in it as well. So if you ever wanted to do the labeling as a separate task for the actual use your own custom image model, you could do that in there as well. So I'm just going to say from a file, that's all I want. Next, and then I'm going to go and get it from local files. So I could have got it from Azure. So, it's storing it there, pardon me. So it's choosing the source. Oh no, that's the source, so the local file's there. And then you're going to store it inside of Azure Machine Learning. That's okay, I don't mind. And then I'm going to go and upload the files. So let's upload the files. And let's go and find the fruit ones. So that's in the AI-102. I've got pictures of fruit and I've got pictures of apples. So let's just do a few. You can see there they've got green apples, and I'll only take 10. Let's see how we go with 10. I know this might be a bit of a mistake, but the problem is I don't want to spend all day doing this. And I want to also upload. Some files were not uploaded. Oh, I wonder why. Let's upload these files again. Don't know what's going on there. So, oh, bit of a problem there. So, what's going on? To continue creation, remove the files with upload errors. All right, I don't know why that's happening. Remove all files that fail. Let's try that again, and we'll just try we'll do 2. So we'll go and get all the bananas open. Causing problems. So that is, I haven't had that before, so that's a new error. I've done this a few times. Why is it having problems? The files can be up because the storage is behind. Okay, so let's do an extra step in here. I'm just going to go over to storage account. So let's create a storage account. Azure storage. So we do that. Okay, storage task, that doesn't sound right. Let's go back to that. That doesn't look right. Let's go back. Storage account. That again. Store that. Oh, there it is there. It's in green. Create. And I'll just leave this as default. JR store AI-102. Blob storage, that'll do. That'll do. Standard LRS. And I just have to create a directory, which is a container. So I'm just going to do that. That's weird. I must have improved the security on that. So hopefully I'll get a little bit further. Otherwise, we'll go and do the lab after the break. Very unexpected that was going to give me that error. No, that used to have a problem like that, but that went away. Looks like it's back again. These subscriptions we use are not production subscriptions either, just to let you know. And they've got previews, so they've always got new features. So all I really need is something like fruit images directory, something like that. And I'm going to create that first level of container, and that's where they're going to go. So I'll go over to here, and I'm going to upload them now. So let's browse the file, get all the bananas. Hope that we don't have problems with that. Upload those. There you go, they're okay. And I'm going to upload the oranges as well. Okay, I'll upload those. And those. So they've all uploaded successfully. So what I'm going to do now is come over to here and go back to the storage. They're going to store on here, that's okay. And now I'm going to go and pick them. So into browse for the storage. Come on, why don't you let me do that? Path. A little bit annoying. If we don't finish this, we'll come back to it tomorrow. So there's my store. There's my, where do I go and get that? Container. No. Connection stream. So, I'm not quite sure what to use there now. So, how do I get, sorry about this, we wouldn't have had all this rigmarole. How do I get the storage path for Azure Blob to put in my labeling project in Azure Machine Learning? It'll fix up the errors there, hopefully. Storage account, blah, 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 contain a name. All right, so I'll do that. I'll go and grab that one. Back in here. Storage account is called JR Store AI-102. The container name was fruit image or image fruit, what I called it. Containers, fruit images. Fruit images, there you go. Hopefully that's okay. No, path is invalid. Is that meant to be blob? Is it? ABFS, is that right? Minimum storage account. Yeah, all right, having lots of problems there. So I'll have to come back to that. I wanted to go and show you how that would work. I don't actually have an existing one there because I haven't created one for a while. Let's see whether I've got any other data sets, because that didn't work. Right, let's just have one more go at loading this data. So create data set, JR fruit, one more go. I don't think that will matter. Oh, okay, maybe storage, selected data, store. Why isn't that coming up? So I might have to grant access to it now. That's a bit annoying. All right, let's go back, one more go, and then we'll give up. So there's the upload path for that one. I probably had to put all of that into the subscription name. Have a quick look, one more delay, and then I'll give it away. vision. Let's try that. One more go. So we go to the AI vision users. Where is it there? Services, documents, OpenAI. Where are you? Sorry about this. So where was that? That was in AI Vision, Dev. It's under Dev. So Dev, AI Vision, and files, object detection, training images. That's not what I wanted. Image classification, training images. There you go. So let's see whether we can take these apples and these bananas. No, it's failing as well. All right, let's come back to that. I'll work out why that's failing. It wasn't failing before, so not sure why that suddenly stopped working. I will try a better way to upload that, and then you can see that later. So what you'll be doing in your lab will be slightly different. You will be looking at the older version. So as you can see, it's tried and tested. It's been there for a while. It works fine. This one is not working at the moment, so sorry about that.
Okay. What is the result?
It's a security error, so it's something to do with not being able to upload it from that file. So it's a restriction, like a security restriction.
Is it like same profile error we are getting? The policy error?
No, because this is actually in my subscription. So if we have a look at the error itself.
Oh, it's your subscription, okay.
Yeah, it's actually in mine. So I don't know whether I've got the errors there. I'd have to go and have a look at the error itself. So there you go. The file couldn't be uploaded because the storage is behind a virtual network. So
yeah, someone has hardened the security. And
yeah.
On your side, if you're not using a lab, but your infrastructure guys probably have done some virtual networking stuff.
Yeah.
Put a storage account behind a VNet that you're not aware of.
Yeah, it looks like something new that's happened. So it worked okay last time, and I was just going to try one because I just went onto the VPN, but it doesn't look like it's even worked that one out. So yeah, I'll have to go and see what else it could be. Sorry about that. Good suggestion though, everybody. Thank you for that, Hebo. And
that happened to me as well. I mean, but I actually have on customer side, some of the security people will come with global admin privileges. They go do some editing or auditing to see if there are any Azure resources not in the private VNets, and then they bring them back to the private VNets. If you build something that is publicly accessible, I mean, that's my experience. Someone from their security infrastructure point of view, they may just bring it back into their VNets where all the storage accounts are.
Yeah.
And all of a sudden you lost your connectivity because because they are doing their own security auditing.
Yeah.
Why do we need to upload the images to the Azure? Can't we search a folder in local and run them through?
No, because they need to be local to be used on the GPU. So the GPU needs to be in the studio. But yeah, you could have VS Code. You could use something in Python there and call it open source. That's okay. So it's all the idea of getting Azure Machine Learning to do the heavy lifting for you first, and then you didn't have to use code to do it. But yeah, bummer. I'll see if I can get that working towards the end of the week anyway, so I can do the demo and try and work out what's going on with that one.
Okay.
And it does look to be security, right? I've just got to go and nut it down.
So, on that point, in fact, James, sorry, I apologize because I actually have customer meetings on and off.
Oh,
so I joined and I saw you were doing machine learning studio, and I thought it was data science course. but you said still the AI, but we're trying to build a customer vision model. That still need to go back to machine learning studio, is it?
Yeah, so the newer version of Vision, so what you might have seen was we're looking at the older version called Custom Vision and the new version called AI Vision. When you use AI Vision, you can use your own resources for it. So that's where you would use Azure Machine Learning just for labeling the oranges and apples, and then you would basically send it back to Custom Vision or AI Vision to do the heavy lifting on the training and the testing. And then you'd be able to set up the API for inferencing
gotcha.
after that.
Right, gotcha. It's actually using Azure Machine Learning Studio to do the previous human work of labeling or supervised learning, like labeling the textures, adding on pictures. Okay, gotcha.
Yeah, so we had a good discussion about outsourcing this to, doing crowdsourcing or getting, these days now they're talking about large language models helping us with our labeling techniques. So maybe more in the tech space, but I could definitely see it helping with products like GPT Omni and things like that. So in the future, we definitely could be using this to, for example, even outsource it as part of your work. You can go and add a workforce in there, or you can come in here and do, there was actually a labeling, ML assisted labeling, so there you can see that option there is possibly something that could help you with automation with the labeling. But too bad I couldn't do the demo. Last month and the month before the demo were fine, so we're beefing up our security, so definitely that could be. So sorry about that.
You just didn't pray enough to the demo gods.
And I didn't do it beforehand. I should have practiced it over the weekend. You get me?
Take a shower, put on some perfume, and then pray to the demo god. That's what I do. Especially
headache cough. Yeah, it's a little bit. Thank you for that. Sorry. So this happens to me all the time. I think I'm jinxed sometimes. All right, just a quick one before we go to the break. Analyzing videos. So this is also an option you can do in there. It's using the video indexer. Now, I'm hoping, beyond hope, that there is a newer version of this coming out that's a little bit faster, because it does take a while to analyze a 2.5 minute or 2 minute video. It does take a while to do that. So maybe about 15 minutes. So it takes a long time. I would love to have something that goes and does videos, because we would like to produce videos that we can then put on YouTube. And of course, we don't want to have to go through and look for all the PII. So it would be really good if we had a better option for ourselves just to do this as well. So facial recognition has limited access, but it's optical character recognition. It'll go and find people. So for example, Eric Horowitz, it's found him. There is, I'm just trying to think of it. No, Sarah, it's gone. So Sarah is actually from New Zealand. She heads up our responsible AI, and various other people in this as well. It'll pick out where topics start. It'll work out sentiment, it'll label, and content moderation as well, associated with, racy content. And then you've got scene segmentation, so where things change. So we'll do all that and label everything it found, and then you'll be able to go to particular points in the video to see where that's happened. So people, you can also get custom insights on people, language, and brands. So for it to find Eric Horowitz, it finds Satya pretty easily because he's everywhere, but Eric Horowitz might take a few images to actually train it to find him. And you can see recognising industry orientation specific terms. That's really important because everything is video these days. If you're on Teams, quite often you're going to be recording things as well. So also does some limited access here. This is the sort of output you get. So you can try that particular, I'm not sure whether we had you can try Video Indexer. Not sure if we had a lab on that one, but I'll double check. So this is very useful when you want to go to a specific point in there. So we've got a couple of different things that we're going to be doing. Let's just go back to the lab, and then we'll have, if there's any questions. So Detecting and analysing faces, we can have a look at that. You can do as many as you want to. Exploring features in Visual Studio. I was trying to do a demo on that, didn't really work very well. So we had a bit of a no-go for that one. And analysing video, you can do that. So let's have a quick look at those ones. Any questions? Had a good discussion on the way too. Well done, everybody. Hopefully it makes up a little bit for the terrible demo.
Well, a question I have is regarding the web-based portals for building AI services, right? So machine learning has a machine learning studio, which I'm more familiar with. AI, I think OpenAI has got an OpenAI studio with a playground. And then Azure AI has got its own studio. And so I sort of like trying to figure out what are the main integrated or IDEs or integrated development environments available in the whole Azure AI portfolio plus ML, right? So it feels like there are new ones being added in, there are old ones being retired. You know, the service is like developers interface. Is there some sort of summary or a diagram showing how these are, you know, how many of this and what are the new ones, what are the old ones, and I don't know. I mean, feels like things come and go.
So I think I see how I've got them all listed there. If I go into AI Studio, this one used to, and I don't think it does anymore, has the 6 dots in the corner here. It doesn't seem to have it anymore. So that's the overarching one, and that will let you play with the OpenAI and AI services in there. It'll also let you do a little bit of fine tuning. I don't know whether that's in there yet, but it might be coming. And prompt engineering with the prompt catalog as well. So some of the things that are in Azure Machine Learning are in there as well. So for the AI engineer, you'd probably be working in here, but you may be working a little bit in ML, machine learning. So with machine learning, the few things that cross over are prompt flow, labeling, and what's the other one? Prompt flow, labeling, and fine tuning. They're all available in there. Fine tuning, RAG, all that sort of thing are available in the Azure OpenAI, which also has a studio there. So that's that one you're saying there's a big crossover between these two. This one is more now focused on creating projects with multiple layers under it. So you would have different layers of services under that. So that's where I think this is the overarching one. But as soon as you go off into a specific one like Language Studio, you're going to go to the specific one. So there's Document Intelligence Studio, there's Language Studio.
Yeah, that's exactly what I meant. You know, so I want, even I have, you know, data science and machine learning background, knowledge and experience. I got lost in all the studios. Like, so many studios. Like which one is overlapping with the others, and then which one should be, you know, our current, you know, focus for an existing project or something. It's great that you line everything up. That's favorite, and I can tell that you need that as well, right? So it's not like it's so straightforward. Everyone go and find out where the studio is and which studio to use and for what reasons, right? So it's so many different hammers. If you don't mind, I mean, if you could export this links to us, I mean, that'd be all great help. At least we have some sort of official confirmation that these are the studios that we need to, you know, get familiar or get a hands on. And I think I only have come across like 5 of them, maybe 4. If that's possible, you could share with us and like export just that.
I don't know whether
not now,
but that's okay. I can definitely give you a list of all of them. It'd be good to have them all in one place, wouldn't it?
Absolutely.
There's even this one designer, right, which is Copilot for, designing DALL-E images and things like that.
Yeah.
I don't think that one's actually working because it uses a different user for that. But that has to be a personal user. So that's a little bit of the roadblocks as well. So yeah, I'll just go through them just quickly. So Azure Machine Learning, AI Studio is overarching, plus a lot more large language. That's all the OpenAI large language. What's this one? I didn't even know I had that one there. What's this one? I don't think I knew what that one was either. I just sort of put it in. Oh, there's the OpenAI Studio. So I think this is just, I don't know. I'll have to go back and have a look at that one. Why that one's different? I mean, these two are probably identical. Document intelligence. So this is part of the cognitive services, the old services.
Yeah.
Document, language, vision, speech. And then you've got the old custom.
The language used to call Lewis, right?
Yeah, Lewis, yeah, that's right.
A few years back, yeah.
I wish they just left it at that, but they tried to rename it and it didn't really work.
Rename and then have a new interface and then have new studios and coming out. Yeah.
And then Copilot Studio as well.
Absolutely, yeah. I was really on top of this. I think before OpenAI. And then after OpenAI, there are new sort of studios and new overlapping services, and then all of a sudden you start getting lost, because if you don't think about it, then it seems to be all natural. But when people ask you questions, so well, should I use this one or use that one? Why they are sort of overlapping? All of a sudden you say, I actually don't know.
I was okay until they added these two, and then I thought, these ones here, and I went, what? Because I was already struggling with the specific ones you see on that first screen. This one is interesting. If you want to try this one out, you can create your own Copilots from scratch. That's a good one.
Yeah.
Copilot Lab, I can't remember what it is. I've got to go back and have a look. But whenever I find one, I make this. So what I did was a concerted effort when I set up my new subscription with the new security. I made sure that I had for example, a persona there that's set up with that user. And then everything I want to use in this space, I actually use through this Edge browser. But when I want to go back to work, I made the decision to say this is my work email rather than my Contoso email. And then that's all based on my logins for work. Right. So, finding out where my certifications are and all that sort of thing. And then, of course, I have a personal one as well. So I set up the 3 personas in Edge, different colours, and then the important things here. But the other thing that's really important, and people don't realise it's there, is collections. So I actually started creating all the studios as a collection. I could have really easily exported that for you and sent that to you. But what I'll do is I'll take a copy of them because they might have my logins in there.
All right. So really
just in case I've stolen some security.
Just URLs.
Just the URL.
Yeah, really.
Yeah. So there's a Copilot Lab as well for trying out prompts, and Copilot itself, which is copilotmicrosoft.com. So there's a whole heap of different studios. Now you're all, very well confused. Good work.
And I have to deal with Fabric versus Synapse as well, right?
Well, there you go. So there's Fabric. I've got Fabric there for you.
Yeah.
I just have to log on and make sure.
I'm writing up an option paper for a customer just to choose between Synapse and Fabric, right? I mean, it's all just. While previously, I think with data and AI, you have a lot less options in Microsoft, and then you sort of like having a more in-depth knowledge about the pros and cons of each. But then there's a lot more adding into the mix, and then it's just that you have to be a sort of a jack of everything and master of none. And because people keep asking me, think, okay, you need to help us to identify the risks and benefits of this over that, right? And so.
Well, I made a mistake of opening my mouth and saying that, and then I got in trouble. So. I stick to what I know better, which is the difference between Azure machine learning and Synapse data science. I stick to just explaining the difference between those two. Otherwise, I got slapped on the saying about the data engineering. So I obviously don't understand it as well as other people do, the fabric part. I know real time, but I don't know all the nuances of some of the other things. So
yeah, some data engineering people, you tell them, oh, there's a Spark engine in it, and then all of a sudden people say, what do you mean by Spark? Right? You have to tell the story about Spark. And New Zealand Spark is actually a very popular mobile phone provider.
Oh, that is confusing.
We're in the
can't enough explain what Spark is.
Yeah.
Oh, yes, welcome a little bit to my world as well, but yours sounds a little bit more painful. I'll help people if I can, but I just got to be very careful the difference between Fabric and Synapse, because I still think of Synapse as being an enterprise grade data warehouse solution, but I think of Fabric as its main selling point is the interconnectivity and integration between all the services. So without having to move your data around. So that's why I sort of think of them as slightly differently, and that might be the way of the future. So
I think that's the Microsoft roadmap, because in New Zealand, it's now a public, it's not news. The New Zealand North has a new Azure region, and it will not have Synapse.
Yeah. Oh, really?
Only Fabric. So that's why I'm sort of being forced to propose a sort of evaluate both in a paper. Yeah.
Okay.
But anyway, I know you're using AI search and open AI services as well for some legal documents. Yeah. Cool. Oh, good discussion. Thanks, Jane.
Good discussion.
The PySpark is a different from Synapse, isn't it? Different.
It's faster. It's definitely faster. Yeah.
And then other leg is Databricks, right? So Databricks is a competitor.
Yeah. So it could be Databricks. Yeah. So I sort of think of Databricks and Synapse being similar, but I think of Fabric as being quite different again. So
Fabric is a collection of these all items.
Yeah, so it looks, the big advantage, I suppose, is that they're taking the Power BI look and feel and applying it to everything, plus workspaces, which is basically something that was only a Power BI thing, is now available for everything you do with Synapse data flows. So the other one I teach is really interesting is the real-time intelligence. That hooks in a lot better with Power BI as opposed to using stream analytics. So that solution seems a lot better, and the time to start the Spark cluster is super fast compared to some of the other platforms previously. I don't know what they did to speed it up, but it's amazing.
It's a software as a service solution that with all the compute clusters in the pool warmed up, and plus the one lake behind Fabric that every layer of service, every service actually can directly access to the one lake, which is the virtual data lake, and that is a real selling point, because all of a sudden you have to manage your own storage accounts or trying to create all these connections between each services. It's all sharing the same lake or one lake. Data virtualization, shortcuts, all that stuff. It's all good stuff.
Yeah, shortcuts are good.
Yeah. And
I suppose it's sort of like linked services, though, aren't they? Sort of.
But how it will fit, because see, if you look at all the building blocks, all building blocks are the entity or kind of ownership of different teams within an organization. So talk about my organization, the data team. You got developers who purely work on ingestion, writing ETL, and they primarily, we are not using Snaps, but other SSIS packages or ADF data factory from Azure to do ingestions. And then the other team, which is a business team, they only focus on Power BI. So it's a landscape in our organization using different part of the job throughout end to end to make it one, one end-to-end solution is something organization need to adapt the entire overarching infrastructure first place, then you can do end-to-end, isn't it? Otherwise, There's no benefit.
Yeah, so that's the data remains in one place as well. You don't have data movement, so it tends to stay in one drive, and that's what's it called? One drive, I think. One lake. Sorry about that. I forgot the terminology. It all sits in the one space, and then of course you can do anything you want to.
The terminology will change next year.
Don't say that. Don't say that. So this is keeping up with AI, I suppose, as well. So you've got lots of cool computes to use in there as well. So yeah, that's why it's still sort of relevant to this class, and we're having a bit of more discussion than probably we should, but it's still relevant because that's where your data is going to be that you're going to harvest, and you need data for this, for AI, definitely.
Exactly.
All right, good discussion too, lots of fun. Let's have a break. For those people in the US, we probably won't do any more content for the day. I'll leave it at that, and then we'll come in tomorrow and we'll try and fix some of those demos that didn't work. And you can do labs for the rest of the day, so that'll be a little bit easier on everybody as well. If you're coming in the morning, you're coming in from the US, do them before you start in the morning. That's all you need to do. And it's not like the labs are dependent on what you're going to learn for the rest of the week. I don't sort of take away information because you've already learned those labs and that you have to remember for the previous one. All good. So Daryl's about to drop as well. All right, thank you so much, and we'll see you tomorrow then, Daryl.
Jane, just one question.
Yeah, so Mohammed, go for it.
Yeah, so did we share the lab keys? I think, a little bit late joining this session, so was there some detail on labs? Maybe I need to capture that.
For this one, you were a little bit late too, were you? I don't think you missed anything because we were talking mostly about data engineering there for a while.
No, so is there some kind of key I have to use for?
Oh, for your lab, yes, of course. Sorry about that. Sorry, I didn't realise that's what you were talking about. Sorry, I thought for this session in particular. I thought you were here earlier. I didn't see you not turn up. So here's the information. Use your personal Microsoft account for that, for the lab. And turn off your VPN is probably the best way. And once you get in there, there'll be a student login you use, and then after that, in Azure, you'll actually be logging on with a user one, blah blah blah.
Yeah.
So yeah, all very similar to other labs. Yeah.
Yeah, this key is enough for me. I know the process, so
excellent.
Thank you very much. Yep.
All right. So after the break, we'll have a look at, I've given you also a link, the GitHub IO link there for Vision, and we'll have a look at which ones we want to do. Now again, some of them may not work because they might have shut down the policies, but ones that should work is your analyze images with Azure AI Vision, classify images with AI Vision Custom, and so really choose what you want to do out of here. I would recommend the first two, maybe the third one, and maybe try that last one as well. So you have all of the instructions here, but if you go back to the lab itself, so this is just before we go to the break, these are the ones that you can have a look at. So there's actually probably down to there. These are all ones you can play with this afternoon. So I'll let you go at your own pace, and let's go to the break. Thanks for the conversation, everyone. Make it so much more interesting when people have fantastic stories to tell. All right, let's see you after the break.
So Jane, what will we do after the break?
After the break, we'll go in and do these 3 labs. So just the ones I put in the chat window. So labs for the rest of the day. And you can launch each one of those individually. If you want to do more than just the 3, then you can use the instructions in this link for the AI Vision that I just went to, this one here. So that's a link that I put in the chat window as well.
You know the problem with the container and stuff? Do we need to resolve that, or we still ignore them?
Which one?
The container creation, the instance.
Yeah, just ignore that. There's no way around that. So I'm going to double check and see whether anyone had any temporary solutions to get around that one. So I'll see if that lab 4 it is, I think actually. Lab 4 containers. I'll check in with the Teams channel we've got internally.
And Key Vault?
Key Vault, yeah, I think Key Vault I'll hang over for tomorrow or the next day. I'll try to get an example there for that working, and also the AI vision, which is the other one that didn't work today, so to do on fixing those. It may not be tomorrow, it might be towards the end of the week, but we'll see how we go. Hopefully I'll be able to fix those, yeah. Yeah, we want to know how to put it in Key Vault, definitely. Yep. Sorry it didn't work the first time. All right.
It's quite late here for me. I'm joining from Texas, so.
Oh, yes.
So maybe tomorrow afternoon I'll do these labs, and then I'll let you know. Right.
Fair enough. That's why we wanted to give you a break in the afternoon, so not a problem at all. Thank you, Marley.
Thank you very much.
Okay, see you tomorrow. All right, for everyone else, let's have a break. See you soon.